Hello. Okay, in class today, I introduced Lhopital's rule quickly at the end, so I'm going to do it again here, and I'll provide a couple of examples. So here's the rule itself. Let's say you take a limit of a ratio, two functions over one another, and the form is 0 over 0 or plus or minus infinity over plus or minus infinity, and only in these cases, nowhere else. Then this limit is equal to this limit. So it's a really handy way to do it. And what I do to indicate that I'm using Lhopital's rule is I use a script L there. Remember, when you do a limit, that this lim expression needs to be in every term, and it's good to justify why you're doing what you're doing. So I think you'll see this when I do a problem. So I plug in here. So when I do this problem, I plug in and I get 0, sine of 0 is 0 over 0. So I can use Lhopital, because it's this form right here. So I use Lhopital, and I get the derivative of sine 3x over the derivative of 7x. So in other words, that's my f, that's my g. So here I'm just taking the derivative. That's going to be cos 3x times 3, remember the chain rule. This is the ddx of this, over 7. Okay, so now I plug in 0. I get cos 0 times 3 over 7. Well, that's equal to 1, so I get 3/7. And that's my answer. That's what this limit equals. And what that means is that the bottom goes to 0 7 times as fast as the top. The bottom goes to 0 faster than the top, because this number is bigger than this one. If this takes 3 units to go, this will take 7 units to go. So it's a little bit over twice as fast, since this is a little bit under 1/2. Okay, so again, we do that here. This is going to be e to the infinity over x to the r. R is greater than 0, so we get infinity here. So again, this is infinity over infinity. And remember, I'm using these to indicate that these aren't actual numbers, so I'm misusing equal. So again, that's a valid form to use this. That's my f, that's my g. Take Lhopital, that's going to be equal to the limit, x goes to infinity, d dx e to the x squared over d to the x, d dx x squared. Well, that's going to be, again, using the chain rule, e to the x times 2x over 2x on the bottom. Well, that's still technically infinity over infinity, but these cancel. So that's equal to the lim x goes to infinity of e to the x squared. And as we saw before, that's infinity. So this limit is equal to infinity. So what that means is that the top, both of these go to infinity. That's what this means. But this goes to infinity way, way faster. In fact, infinitely faster. So as x gets large, this ratio right here is infinite. As x goes to 0, this ratio right here is about 3/7. I hope that makes sense. Thanks.